This is
Hi, I'm Andrew.
I'm Louis,
And I'm Kaiwen behind the camera.
and they have asked me to demo a DJ emulation project. So this is signal processing competition, ECE Pulse 2016. They were provided with an array of sensors provided to them. They were also allowed to bring their own hardware. So with an Arduino, they've created a DJ emulation software using a Nintendo digitizer or a touchpad, and this is kind of like a scratch pad. So imagine if you're a disc jockey, and you kind of have like a scratch thing, right? It goes, yeah. Exactly. So this is what makes that sound, right? Now with this is an ultrasound that's playing a couple of different songs. So if I up the volume with this left potentiometer, it's playing one song. Right now it's playing a superposition of two songs. So if you imagine, let me just turn this down. Kind of, here's the peak volume of two different tracks, and they kind of overlap in the center. So as you move your hand across this, you'll have song 1 being very loud, song 2 being very loud, and you have a superposition. So if you turn the volume up, you can look at it. So this is the first song. Then there's a superposition, and there's the second song, right? And then there's the scratch, right?
Hi. So I'm Kevin. So now I basically introduce the difficulty points of our project. So the software we are using to process and play the video is MATLAB. Maybe many of us have used MATLAB for audio processing, but that is to process an audio file as a whole. But it's quite hard to using MATLAB do real-time processing, which means that according to the instruction from user, you change how you process that audio. So the way how we do it is to break the audio file into various fragments or clips, and then we play them consecutively. But we do not directly do this because if we do this just one by one, there will be breaking point between them, so that there will be a high frequency noise and make your music sounds very bad. So the way we do it is to let multiple of the fragments playing together and let them overlap, so that at each breaking point there is another fragment playing, so that it can cover and eliminating the breaking point effect, and there will be no such high frequency noise. Another difficult point is that these two systems work at entirely different frequencies. So the MATLAB, because it's reading the audio file and process on it, it is very slow, about 5 Hz. But the Arduino is only deal with the sensors, so it's quite fast and working about 100 Hz. How can we communicate these two devices properly using an asynchronous communication protocol? Actually, we add a handshaking mechanism so that every time it sends the information, both the computer and the microcontroller will be acknowledged, and they can receive the information from each other correctly.
And now I would like to talk a little bit about how our Arduino code runs. So what happens is, the Arduino is used to gather a variety of these sensors data, and while it's not used, the Arduino is not used to process any sound information. It is definitely at work at gathering all these sensors and putting them in a format that we will later send to MATLAB. So the Arduino, after gathering each raw data, it organizes data in a structured way, so that when it arrives at MATLAB is able to interpret this information and turn it into something useful. Now, as you can see, this is the Arduino code, and this is written in structured into different sensors. Second, we have the code for the ultrasonic sensors, which gathers distance from 0 all the way to 4 meters. But in order to get In order to control the ultrasonic sensor accurately with our hands, we have decided that we would like to only include a certain segment of space that can be used to control our hardware. Third, we also have a code for pattern recognition on the scratch pad. As you can see, the touchpad is only gathers raw x and y coordinates. So in order to simulate the scratching motion, we have to go up and down along the pad, along the surface of the pad, and each time we change direction, we would like to use that as the scratching motion, just like a DJ scratches his disc. And in order to do that, we would record one direction, and every time it changes direction, that will be counted as a scratch, and that information can be then sent to MATLAB to manipulate the sound up files. Okay, so in order to initialize the start of a packet to synchronize, so that MATLAB can synchronize the communication with Arduino properly, we send a -1, which in our case we never use a -1 because this is all physical values. And a -1 will signal the start of communication, and then Arduino would begin by sending first the analog signals, which is the potentiometer sensor readings, and then we have the distance of placement of the hand on top of the ultrasonic sensor, and then lastly we send the scratch signal.
Say hi. DJ Kevin. DJ Kevin. DJ Kevin.